In this last week, I've been trying to make a lot of random programs off the internet compile with my compiler. One of the programs I've been trying to make work is this wcap utility. Wcap is a utility to record the screen by Martins of Handmade Network fame. And the reason I've been trying to make this work is that it has a simple build script, so I can easily build it with my compiler by just replacing this CL invocation with an HLC invocation. But one thing it needs is c11 atomics, and I didn't have that implemented. And so this last week, I've been trying to implement c11 atomics. So this is the stdatomic.h file. As you can see, it defines a bunch of macros, and then there are some generic functions. Usually I think compilers implement these generic functions by using compiler intrinsics, but I sort of have a policy to use as little compiler intrinsics as I can. So I've decided to implement these generic functions using the c11 generic keyword. But the c11 generic keyword is not yet implemented in my compiler. So this is what I want to do today. The c11 generic keyword allows you to specify an expression and then, depending on the type of that expression, choose one of multiple expressions to actually execute. I don't really like this keyword because it very much feels like a complicated overloading C++ sort of feature. But it is a mandatory C11 feature, so let's implement it. And the other reason is obviously because I've decided to use it for C11 atomics, which is a feature that I sort of like. Here I've provided a little test file that just either calls floor f, floor, or just returns the original expression. Usually this generic keyword is only ever used as a define because it doesn't make sense to use it in any other way. And let's make this one work first. And apparently the draft website is down, so that's great. Here's the generic selection on MSDN. The way it works is it's a primary expression initiated by the generic keyword, then an open paren, an assignment expression, and then one of these association lists. Each item in the association list is a type name followed by an assignment expression or a default followed by an assignment expression. Why are these assignment expression? Well, assignment expression simply means it is not a comma expression. That is relevant here because these have commas in them. So the way that works in my code base is that I say pass an expression but skip comma expressions. This is a primary expression, so let's go to the place that I implement primary expressions. Right, I kind of baked the prefix expressions and the primary expressions into one switch. But here's the switch that does it, checks for a bunch of different tokens, essentially. Now we have to check for the token generic, which does not exist yet. The way to add a keyword is to add it to the keyword table entries and add a token for it. At some point, some code builds a perfect hash table of all of these strings and then maps them to these tokens. So we are going to simply add the generic token as well. So for now, we simply get the generic token. Then after that, we expect an open parentheses. Then we pass the assign expression. Again, assign expression simply means pass expression with skip comma expressions. Then I continue to pass the generic while we don't have a closed paren. Then if it's not a closed paren, it has to be a separator token, like the initial comma or any later comma. And so I tell it, okay, I expect either a closed paren or a comma while passing the generic association list, and I allow trailing comma, so here I also have to check after the comma if there is a closed paren. And now the thing we have to check here is we have to either pass a type name now or a default. So let's first check for default. Now if it's not default, we have to pass a type name. So for the type name case, we first try to pass a type for cast off or size off. This is simply currently sort of misnamed. Maybe it should be maybe pass type name. But anyway, we pass one of these type names essentially is what this does. And then I check if that succeeded. Otherwise I report an error that we need a type name or a default. And currently I try to change the way I handle errors by simply making it work afterwards. And so in this case, I say that the type specifier is now. Then I again expect a token, get the expression, and then we choose the expression if it has the same type as the type name. This is wrong. We need to take the choice. Right, we pass the choice in the very beginning. So if the types are equal between the type specifier, that we passed here and the choice, then we want the chosen expression to be the expression which we passed here. Okay, so in the end, we want to check, first of all, do we have a chosen expression? If yes, we want to take that one. Otherwise, we want to take the default expression if it exists, or we want to report an error. Yeah, I did exactly what I said. If we have a chosen expression, operand is chosen expression. Otherwise, if it's the default, if that does not exist, I report a badly worded error right now. But maybe I'll go back eventually and fix this error up. We'll see. Now let's try to compile it. Okay, that compiles now. So let's test it out on test.c. Warning at equals. Wanted int given float. Wanted int given double. Okay, yeah, these don't cast to anything. So that makes sense. Floor f still returns a float. Double of floor still returns a float. Why are there 3 warnings now? Wanted int. There are 2 in line 18 for some reason. So that seems incorrect. So let's step through the code and see what it does in this case. Get the generic, we expect the open paren, we get our choice. What is our choice? It's an identifier. Sure, the identifier is D, that makes sense. Maybe I should put up the code. So it's this D, which then lands in here. We pass a type name. Okay, I think I know actually what's happening here, and that's actually, it's correct, because this was reporting a warning, because it expects a float, but it got a double in the form of this A. So all of these expressions are passed, with A being the argument. That's why you usually do this and leave out the argument, but I wanted to have a default case. Okay, but that means that works. I think, the passing. So let's try it on stdatomic. And the way to do that is to just simply run it on wcap. So the project right here by Martins that I have checked out here. So the only difference, the only alterations I have made is to patch up the CL to being HLC, as you can see. And now I want to simply run this build script. And then we get our breakpoint at generic. Okay, so let's try that again after removing the breakpoint. Error value undeclared identifier. See what that's about. Maybe it's related. Seems to be related, seeing as it uses an atomic fetch add. I currently don't respect any memory ordering and say every memory ordering is memory ordering sequentially consistent. And then we have this atomic fetch add, which is supposed to take an object and an operand, but I call it with object and value. Because I copied these from Atomic Exchange. Let's try that again. Still no bueno. Here's another one. And now it crashes somewhere deep inside the emit code. That's great. It's simply asserting that whatever the type is, it is either integer type, pointer type, float, or float type in emit code for plain condition. This probably means it is an atomic integer type. I recently introduced these two. Atomic integer types to support stdatomic. So the only atomic types, as you can also already can tell here, are the integer atomic types. I didn't care for any other atomic types for now. If I'm only loading it here, it's fine to say atomic integer type as well. On other architectures, I think I have to emit a special load instruction. But also probably a mid-load should handle that then. On the other hand, I kind of want to nuke the whole x64 backend and rewrite it at some point. So it doesn't really matter anyway. Let's try that. Let's retry it after fixing the assert. Assert fired decal memory location in printconf. Well, the sun is coming out. I can barely see anything. This tackles some way different code, but let's try to make it work. So this is a declaration which is DLL export. So it's supposed to be exported. It is referenced by something else, maybe or not. And it is referenced by something else, but we have not decided for whatever reason to pass as initializer. Does it have an initializer? Does have an initializer. So I think probably the oversight is where we try to assign this flag. Here, we compute reachability information because we only want to emit functions, also now declarations, that are reachable from main. I assume somewhere here I do the initializer thing. Right here, evaluate static initializer. But I assume I don't do these for root level things. Right, so here we sort of have to do this exact same thing for root level things. Which we appear to be already doing for functions. This whole thing seems sort of badly organized. So let's make a comment about that. And fix me. or cleanup. I'm sort of surprised that some things like this slipped by for so long, but whatever. Declaration. Okay, and with that, compiled. That is definitely success for today. Let's try to run it. I don't know how to run it. I've never tried to use the original version or anything. So we have an executable. That didn't do anything. Okay, but we are running. I don't know. Oh, it's already running. So it is working. I don't know what it does. So I call that success. Thank you for watching, and maybe see you in the next one.